Hello, it's Dave Giles here for the next lesson of Cambridge International Education IGCSE Physics. And today's lesson is a little bit different because as part of the IGCSE, you need to be able to resolve vectors. And in order to do that, you need to have an understanding of maths. You need to have an understanding of trigonometry and Pythagoras theorem. Now, because quite often this unit is taught at the beginning of year 10, and you don't do trigonometry until quite often in some schools till year 11, I'm doing a lesson on maths today rather than physics, so it'll be fairly short. And then this will be then used in the next lesson, which will be on resolving vectors. So today's lesson, like I say, maths needed for resolving vectors. I want you to recall names of parts of a triangle, use Pythagoras theorem, and apply trigonometry to find angles and lengths in a triangle. So we'll start with naming the parts of a triangle. So here's a triangle, right angle triangle to be more precise. And we've got an angle here, and we've got different parts, the hypotenuse, the opposite, and the adjacent. So the first one to mention is the, 2 seconds, is the hypotenuse. Now, a hypotenuse is always the long one, okay, the longer side, and it's opposite the right angle. So this here is the hypotenuse. And then we've got the opposite. So opposite just means opposite the angle we're talking about. So it's over here. And the adjacent is the other one. It's the line between the right angle and the angle we are looking at. This is the adjacent. So that's the first learning objective complete already about recalling names of parts of a triangle. So now we're going to look at Pythagoras theorem. Now, quite often you might have done this in year 9 or 7, 8, and 9 in school. So this bit you may already know. If not, just a quick recap. And then after that, we'll move on to the trigonometry, which you might not know yet at the start of year 10. So maths for resolving vectors, Pythagoras first. So Pythagoras theorem states that the hypotenuse squared equals the opposite squared plus the adjacent squared. So I've put some numbers on here, 10 centimeters and 6 centimeters. And I said, calculate the hypotenuse. So hypotenuse squared, like I said, is opposite squared plus adjacent squared. So hypotenuse squared is 10 squared plus 6 squared. So the hypotenuse, so now I've square rooted both sides. And I've got the hypotenuse is 10 squared plus 6 squared, all square rooted, which gives me 11.7 centimeters. A quick one for you to try yourself there. Okay, same working out, same methodology, and you should get 17.5 centimeters. So here's a little bit different. I've asked you to calculate the adjacent. So I'll work through this one and then let you try one yourself. So same formula, but we're going to put our numbers in. So 15 squared, that's the hypotenuse, equals 10 squared, which is the opposite, plus the adjacent squared. So the adjacent squared is 15 squared minus 10 squared, or adjacent. To get it on its own, we square root both sides. You get 11.2 centimeters. Now try this yourself, but this time you are calculating the opposite. So how long is this length, this side here? And pause it. And the answer is 229 centimeters. No, I'll just put these on the board, put these on the screen, and you can pause it and work your way through. I'll put the answer on in a few seconds. And the answers. Okay, so that is the first learning objective about using Pythagoras theorem complete. We will now move on to trigonometry. So this is where we've got angles. So the thing you've got to remember for this is SOHCAHTOA. So S is sine, cat is cos, and TOA we use tan. So sine, so SO means sine, theta, where theta is an angle, equals opposite divided by hypotenuse. cos theta equals adjacent divided by hypotenuse, and tan theta equals opposite divided by adjacent. I'll leave your formula on. So calculate the hypotenuse here. So you've got to look at what we are given. We're given the angle, and we've got the opposite, and we're asked to work out the hypotenuse. So we need a formula with hypotenuse and opposite in. So hypotenuse and opposite is sine. So sine theta is opposite divided by hypotenuse. So sine 30 is 5 divided by the hypotenuse. So rearrange, you get hypotenuse is 5 divided by sine 30, which equals 10 centimeters. Okay. So here's one for you to try yourself. Give you a few seconds or just pause it. Okay, so you should get an answer of 4.91 centimeters. This one's a little bit different. We're now being asked to calculate the angle. Okay, so we've got the adjacent and asked to calculate. So we're given the opposite and adjacent, asked to calculate the angle. So opposite and adjacent means we're going to use tan. So tan theta is opposite over adjacent. Tan theta is therefore 8, the opposite over the adjacent of 10. So tan theta is 0.8. So it'll go from theta to tan theta. You have to use inverse tan. So if you look on your calculator, it'll be tan to the -1. So you do inverse tan of 0.8, and that gives you 38.7 degrees. Even if you're following along, just type that in your calculator, just double check you get 38.7. It's important to check you have got your phone, so your calculator in degrees mode. You'll see a little D at the top. I normally use a Casio. If not, you might have to go into the mode and change it. If you see an R at the top, that means you're using radians, which we don't want to use today. Okay, so here's one for you to try yourself. And I'll put the answer on now. 48.2 degrees. So, you can now pause this and attempt to calculate the length of each unknown side. Put the answer on now. And then pause it again, find each of the unknown angles. Put the answer on now. And that's it for today's lesson. The next lesson, it will be on resolving vectors using maths, so basically using the trigonometry and Pythagoras, which we've looked at today. And I'll be uploading that lesson very soon. So thank you very much, everyone, and I will see you in the next lesson. Bye-bye.